Hello, good morning students. How are you all? I hope you are all doing well today. So students, today we are going to start a new topic. Yes, that is arithmetic progression. Okay, so let's see some example of patterns here. So here you can see patterns in nature. Okay, so here when we throw a stone in the water, you can see the pattern here. Okay, yes, then pattern of circular rings on the surface of water. You can see when we throw a stone in the water, so pattern of circular rings on the surface of water. Yes, now here you can see what is this? Yes, rainbow. So the pattern in rainbow, colors pattern in rainbow. Okay, you can see here the 7 colors. Okay. Yes, now here honeycomb, the pattern you can see. Now patterns in sunflowers. Yes, so here some examples of patterns in day to day life. Holes of honeycomb you can see. Now here grains on a maize cob. So yes, the pattern here. Spiral on a pineapple. You can see some pattern here. Yes, like this. So spiral on a pineapple. You can see some pattern here. Here, what is this? Yes, pine fruit. So here you can see pattern like this, circular spiral on a pine cone. Yes. Now some patterns in animal. Okay, you can see pattern in some animals like this. Here zebra, the patches on the skin of the animals. You can see zebra here. Okay, and yes. Now here the butterfly, pattern of wings of butterfly. Yes, so here some examples of pattern in day to day life we see. Yes, patterns in designs. You can see here the superstore here. So you can see the dress here, some pattern here. Yes, now here the patterns in mat on the, yes, you can see pattern observed on the mat. Yes, pattern in patterns in constructions. So you can see some patterns in constructions here. Yes, you can see the similar pattern here, and in the back side you can see similar pattern. So the pattern in constructions. Now here you can see some patterns in constructions. Okay, now you can see the patterns in tile. Okay, so here different type of tiles are here, and you can see some patterns, tile patterns, rangoli patterns, and yes, now we will talk about number patterns. Okay, so example for number patterns. So here one that is a one tile, that means 1 here. When we add 3 more, so that is 4, and yes, when 5 more, then 9. Again when we more when we add, yes, like this, so you can see it's a 16. So square patterns are here. Yes, so 1, 4, 9 and 16. What is this? Yes, this is the pattern of square numbers. 1, 4, 9, 16 are square numbers. Okay, so here some examples of numbers pattern here. Now here you can see 4 persons sitting in the, yes, on the table. You can see here when we increase the length of table, you can see when then the number of people, yes, 2 people more increase when length increase the table. Similarly again and again So you can see the pattern are formed here. Yes, 4, 6, 8, 10. Yes. Now here annual day celebration. So students are making pyramid here. You can see. So 1, 5, then 4, then 3, then 2, then 1. 5, 4, 3, 2, 1. So this is the pattern here. Okay. So pattern got by reducing 1 from the previous number. You can see 5, then 5 minus 1, yes, 4, then 4 minus 1, yes, 3, okay, and yes, 3 minus 1, 2, and 2 minus 1, that is 1. So that is the pattern here. So pattern got by adding minus 1 to the previous number, we can say that. Now here one more example of patterns. So here students, the patterns you can see 3, the number of glasses are 3 here. So 3, 3, 3, 3, 3. So what we, so pattern got by adding 0. Okay. So here we see 3 examples. Okay. So the pattern here, so today we will discuss about the topic arithmetic progression. That means AP, we can say AP, arithmetic progression. So what is an arithmetic progression? So you can see some pattern of numbers here, 4, 6, 8, 10, 5, 4, 3, 2, 1, or 3, 3, 3. We have 3 examples here. So an arithmetic progression is a list of numbers in which each number is obtained by adding a fixed number to the preceding number except the first number. You can see here 4, 6, 8, 10. Okay. So what is an arithmetic progression? So arithmetic progression is a list of numbers in which number is obtained by adding a fixed number to the preceding number. Okay. So let's see some example like this, 4, 6, 8, 10. So terms of the arithmetic progression. So here the fourth, that is first term, our, that is our first term, 4, that is our first term. Now when we add 2, okay, for, and yes, first term we can write A1. Okay, first term denoted by the letter A1 or T1. A1, that means first term, or T1, we can write T1 also. So first term denoted by the letter A1 or T1. Okay, or we can say directly A. Now 6 is the second term here. Okay, that is our A2 or T2. A2 or T2, that means second term. Now 8, so 8 is the third term here, that is A3 or T3. 10, that is our fourth term, or we can write T4 or A4. Okay, and so on. So that is a infinite arithmetic progression, that means endless pattern here. Okay, so that is our infinite arithmetic progression. Okay. Now 4, 6, 8, 10. So 4 is first number here, then 6, that is our second term, 8, that is our fourth term, and 10, that is our fourth term. Now you can see, student, the difference between, yes, each now, yes, 6 minus 4, so that is 2, 8 minus 6, that is also 2, and 10 minus 8, that is also 2. So difference are same here, that means difference is constant here. So each term is got by adding a fixed number to the previous term, or we can say difference between any two consecutive terms is constant here, that is common here. Yes. Okay. So remember always, for an arithmetic progression, difference between any two consecutive terms is constant, or we can say common. Okay. Here you can see 2, 2 and 2. G, that is the common difference is 2 here in the for this AP, common difference is 2. Our Yes, we can denote it by the letter D, common difference, that is D here. Okay. So first term, that is 4, common difference, that is 2 here. Then when we add 4 and common difference 2, then what will we get? Yes, second term, 4 plus 2, that is second term. Again second term plus 2, yes, we will get third term. Then again third term plus common difference, so we will get fourth term, and so on. Now here the pyramid, here you can see. So 5, 4, 3, 2, 1. So is it an AP or not? Yes, it's an AP. So here you can see 5, 4, 3, 2, 1. The difference between two consecutive terms are same here. 5 minus 4, yes, 1. 4 minus 3, yes, 1. 3 minus 2, yes, 1. So yes, difference between two consecutive terms are same here. That means the common difference are constant. Yes. So this is an AP. Okay. Now here the first term, that is 5 here. Okay. First term is 5 and common difference, that is minus 1 here. Okay. Finite arithmetic progression, that is finite arithmetic progression. So first term A, that is 5, and common difference B, that is minus 1. Common difference, student, how can we find common difference? So remember always common difference is term 2 minus term 1, or we can say term 3 minus term 2. Okay, or similarly term 4 minus term 3, term 5 minus term 4. So remember always how can we find common difference? So yes, T2 minus T1 or T3 minus T2. So here 5 minus 1, that is 4, 3 minus 1, 2, and 1, yes, 2 minus 1. Now here one more example of arithmetic progression. 3 comma 3 comma 3 comma 3 comma 3, you can see. So all are 3 here. So in this case the first term, that is 3, and can you tell me the common difference here? Yes, common difference is 0 here. Okay, common difference is 0. 3 minus 3, 0. Okay, so 3 plus 0, 3, 0, 3, again 3 plus 0, 3. Okay, so that is and also an AP. Okay students, now it's question time. I have a question for you. For the following AP, write the first term and the common difference. Okay, and yes, I am giving you 30 seconds. So which option is correct here? Option A is equal to 3, D is equal to minus 2. Option B, A is equal to minus 5, D is equal to 4. Option C, A is equal to minus 5, D equal to minus 4, and option D, A is equal to 3 and D equal to 4. So which option is correct here? Yes, write the first term and the common difference. Okay, so okay student, times up. The you can see common difference, that is yes, first term. So minus so minus 5 is our first term. Okay, so minus 5. So option B, A minus 5, and option D, A minus 5. So minus 5, that is our first term. Now find common difference. So how can we find common difference? Yes, common difference is equal to T2 minus T1. That means term 2 minus term 1, second term minus first term. So here second term is minus 1, first term is minus 5, and yes, subtract, so minus minus, so minus minus plus. Okay, and yes, minus 1 plus 5, so that is 4. So D is equal to 4. That means the second option, A is equal to minus 5 and D is equal to 4, our that is our right answer here. Okay, yes. Now let's move the next part. So students, here we see different examples of an AP 4, 6, 8, 10. The common difference is 2 here. In the second example 5, 4, 3, 2, 1. So you can see the common difference is -1 here, and in the third example 3 3 3 3, the common difference are 0 here. So in all cases the common difference, so when we talk about common difference, so in AP the common difference can be positive. You can see the positive common difference here. In the second example you can see the term the common difference that is negative, and in the third case you can see common difference will be 0 here. So in AP the common difference can be positive, can be negative or 0. Okay, so remember always. Yes, now students, it's an activity. Can you find just the arithmetic progression? Can you find out the pattern here? Yes. How many patterns and how many APs are here? Yes, you can see. Do you find an AP here? Yes, so you can see first AP 1, 2, 3, 4, 5, 6, 7. Yes, second AP 8, 9, 10, 11, third and fourth. Okay, so and you can see here 1, 8, 15, 22, 29. Yes, second, yes, 2, 9. Now you can see yes, 14, 20 and 26. The difference between two consecutive terms are same. You can see 20 minus 14, yes, 6, and 26 minus 20, yes, 6. So of course that is an AP. Now here 1, 8, 15. So all are APs here. Now students, it's question time. I have a question for you. So write first four terms of the AP when the first term A and the common difference are given as follows. So yes, I am giving you yes 45 seconds for this question. Okay, so write first four terms of the AP where A is equal to -2 and D is equal to 0. Okay, now here you can see the common difference, yes, that is 0 here. First four terms of the AP when the first term A and the common difference first term A and the common difference are given as follows. You can see yes. Okay students, so time's up. The right answer is yes. You can see common difference is 0 here. That means yes, no the difference between two consecutive terms are 0 here. So that means yes, -2, next term -2, again -2, again -2. So all are -2 here. Okay, so option A, yes, that is our right answer, option A. Okay, yes, correct. Now let's move the next part. So students, you can see one example here, 1, 8, 15, 22 and 29. So first term, yes, that is 1 here. Okay, now second term, yes, that is 8 here. And how can we find common difference? So A2 minus A1 here, that is A2, that is A, or we can write A1. Now A3, that is A4 and that is A5. So here A2 minus A1. So A2 minus A1. A2 is 8 here and A1, that is 1. So 8 minus 1 is equal to 7. Now A3 minus A2. So yes, difference between A3 minus difference between A3 and A2. So here 15 minus 8. Yes, of course 7. Okay. Now A4 minus A3. Yes, A4, that is 22 and A3, that is 15. So 22 minus 15. So again 7 here. Yes. So you can see common difference between the two consecutive terms are same here. Yes, A5 minus A4. So 29 minus 22. Yes, so what will we get here? So 29 minus 22, that is 7. That is equal to 7 here. So you can see difference between two consecutive terms are same, 7, 7, 7, 7. That means yes, is 7, 8, 15, 22 and 29. Yes, this series in an AP. Okay. So the difference is common. So hence it is an AP. Okay. So students, remember always the yes, the definition of an AP and the pattern of an AP. The common difference are same always. Yes. So A is equal to 1 here and common difference, that is 7 here. Okay, now it's question time. Which of the following are APs? So first is 0.2, 0.22, 0.222 and 0.2222. Second one 1397. So the options are 1 and second both, only one, only second and none of these. So yes, I am giving you 39 seconds for this question. Okay. So which of the following are APs? First and second both, only first, only second and none of these. Let's now check the pattern. Okay. The condition of an AP, you remember always. Okay. Yes. Yes, okay student, time's up. So the right answer is yes. You can see here in the okay, let's check one by one here. Okay, so 0.2 and 0.22. Now can you tell me the condition of an AP? Yes, common difference between two consecutive terms are same. Okay, so here first we find 0 common difference between second term and first term. So 0.22 minus 0.2, 0.2. So 2 minus 2 0, so that is 0.02. Then third term minus second term. So third term minus second term, yes, 0.222 and 0.22. So that is 2, 2 minus 2 0, 0, and you can see here the difference are different here. Okay, the common difference are not same in the first AP. So yes, it's not an AP. Okay, and now second term. So second term minus first term. Okay, so D is equal to T2 minus T1. Okay, so T2 is 3 here. So 3 minus 1. So 3 minus 1 is equal to 2. Now find minus 3. That means third term minus second term. So third term is 9 minus 3, that is equal to 6. So 2 and 6. You can see here the difference between two consecutive terms are not same here. That means both are not an AP. Not one, not second. Both are not an AP. So none of these the right answer here. Option D is right answer. Okay. Now let's move the another part, students. So yes, few more examples of AP from daily life situations. Okay, so let's see some examples here. You can see the kilometer, speedometer you can see here. Okay, speed and kilometer. So the taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So in this case you can see for first kilometer, yes, that is rupees 15, that is rupees 15. Now for second kilometer, so 15, that is first kilometer, that is yes, charge for first kilometer, that is 15, and for second kilometer, that is 8. So 15 plus 8, 23. Now fare for third kilometer, so 23 and 8 and so on. So 15, 23, 31, okay, and yes, now next one will be 39, okay. So that is the example of an AP. So here each subsequent term is obtained by adding a fixed number 8 to the previous term. You can see when we add 8 in the 15, so 15 plus 8, so we will get second term. When we add 8 in the second term, so we will get third term, okay, and so on. So it is an AP, okay. So here A is equal to 15 and common difference, yes, of course, that is D here, that is 8 here, okay. So D is equal to 8. Now here you can see the bottom rung is 45 centimeter in length. You can see the ladder here, okay. So in this ladder the bottom rung is 45 centimeter in length. You can see that is a 45 length, 45 centimeter. The second one, the third one and the fourth one. So from the bottom to the top are respectively 45, 43, 41, 39, 37, 35, 33, 31. So you can see the pattern here, okay. The difference between two consecutive terms are same here, okay. Now students, in the following situation an AP. So you can see the amount of air present in the cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time, okay. Let's see the situation here. So here in this case you can see vacuum pump removes 1/4 of the air, okay, from the cylinder. So first time let us assume the initial quantity of air as 1 here. Let us assume the initial quantity of air is as 1 here, okay. So first time the vacuum pump removed 1/4, so that means 1 minus 1/4. So the quantity of air removed is 1/4 of 1, okay. So that means 1/4. So remaining quantity of air is in the cylinder, so 1 minus 1 by 4, okay. So what will we get here? Yes, 4 1 is 4 and minus 1, so 3 by 4. So the 3 by 4 part is the remaining air in the cylinder. Now then again 1/4 of the 3/4, okay, 1/4 part of the 3/4 will be removed. So 1/4 into 3 by 4, that is 3 by 16, and then remaining quantity of air, yes, that is 3 by 4 minus 3 by 16, okay. So when we solve it, so what will we get here? So you can see 12 by 16, or we can write 4 3 is 12, yes, 9 by 16. So yes, 9 by 16. So next one, next part. So the quantity of air, you can see the quantity of air removed at the first two stages is 1 by 4, 3 by 16. We can find third step also, okay, but similarly we can find third step. So here you can see 1 by 4 and 3 by 16. There is no uniform decrease in the quantity. You can see there is no uniform decrease in the quantity. So that's why it's not an AP, okay. Hence it is not an AP, okay. Okay student, now it's a value based question. Who according to you is responsible for keeping the school premises neat, green and clean? Oh, okay, I am giving you yes, 30 seconds. First option is teachers and staff of the school. Second one, cleaning workers appointed by the school. Third one, students of the school. And yes, fourth one, all of the above. which option is correct according to you? Okay, so that's a value based question. So yes. Okay, student, time's up. So the right answer is option D, all of the above. Okay, so the responsibility for keeping the school premises neat, green, and clean. Yes, teacher and staff of the school, cleaning workers appointed as well, student of the school as well. So all of the correct, all of the above. Okay, yes. Now, students, let's see one more question here. Now solve this question. Okay, write first four terms of the AP when the first term A and the common difference are given as follows. Now tell me the answer. I am giving you 20 seconds. We have already discussed about that question in previous slides, but yes, now tell me which option is correct here. Yes, so the right answer is option A. Okay, remember always here in this case you can see first term, that is A minus 2, and common difference, yes, common difference is 0. That means no, the difference between two consecutive terms are 0. That means yes, T2 minus T1, yes, 0, T3 minus T2, yes, 0. Okay, so in this case T3, T1, T2, T3, T4, all terms are equal in this case. Okay, so minus 2, minus 2, minus 2 and minus 2, yes, that is in AP. Okay, now here one example is the following situation and AP. So the amount of money in the account every year when rupees 10,000 is deposited at compound interest at 8% per annum. So can you tell me, is the following situation an AP or not? Yes, so here you can see the amount of money in the account every year when rupees 10,000. So amount in the beginning, that is 10,000, and deposited at compound interest at 8% per annum. That means when first we find first year compound interest. So can you find this? Yes, can you tell me the formula? How can you find interest for first year? Yes, that is P into R into T by 100. So here 8%, that means 8 by 100 into 10,000. Remember always the formula of interest, that is principal into rate into time by 100. So rate, that is 8% here, and principal, yes, of course, 10,000, and yes, time, that is 1 here. So 8 by 100 into 10,000. Okay, so yes, 0 2 0, that is cancel out, so we get 800 in first. So A1 is 800. Okay, now again, because the yes, the interest is compounded, so that means second year principal will be 10,800. Okay, so now again we find the interest, so that is 108 into 8, 864. So 8 A3, 10,800 plus 864, so that is 11,664. So you can see the first term, that is 10,000, the second term, that is 10,800, and in the third term you can see 11,664. Okay, and so on. So here you can see the difference between two consecutive terms. Yes, here 800, the difference are second term and first term, that is 800, and the third term and the second term you can see that is 864. So in this case, each subsequent term is not obtained by adding a fixed number to the previous term. So that means Yes, this is not an AP. Okay, here it's not an example of an AP. Okay, so remember always when the interest are compounding, that means that time it's not an AP. Okay, students, now it's a feedback question. How do you feel? Okay, so I'm giving you 25 seconds. Okay, so today we discuss about arithmetic progression. We see some patterns in real life examples. Okay, so I hope you enjoyed today's class, practicing. Okay, and remember always the property of arithmetic progression. Okay. Okay. So the property of arithmetic progression, remember always, yes, the common difference are same in an AP. Okay, that means yes, suppose that we have a AP A1, A2, A3, A4, A5. Okay, so the common difference is equal to A2 minus A1, or yes, common difference is A3 minus A2. That means the common difference between two consecutive terms are same always. Okay, so it's a basic property of an AP. Okay, remember always this property. Okay, now okay, it's over to time to over the class. I hope you enjoyed today's class. Okay, keep practicing. Bye bye, take care, see you in the next class.